Welcome to MTT, Northern Virginia Community College. I've set up some little videos about the notes for Unit 1 to try to get everybody off on a good start. These are the 1A notes. They're not exactly the same that are on Pearson. I've expanded it a bit, and I've tried to add some extra information that I find very helpful. Most of the notes always start off with some vocabulary questions, fill in the blank type things, and then they go through some examples and work their way through things. You'll get along, you'll figure it out pretty quickly. But I do think these notes are set up very nicely. So we'll just do a couple vocabulary things to start off. And the product AB, A and B are called factors. So really when you do 3 times 5 equals 15, both 3 and 5 are factors of 15. Also, the other pair of factors is 1 times 15. So those would be all the factors of 15, those 4 numbers. A multiple of a natural number is a product of that number and some natural number. Oops, there we go, now you can see it. Really, there is a multiplication chart that I really want you looking at. Now, I've copied a couple rows of the multiplication chart so we can play around with them. But for the multiples of 2, it's 2, 4, 6, 8, 10, 12. Now, pretty much these are easy ones that you can handle. But they have the multiplication chart. It is a 1, 2, 25 multiplication chart. And it is under document sharing in MyLabs Plus. Please print out a copy for you. I cannot tell you how helpful it is. A lot of the times I think it's better than the calculator because it will tell you a lot more things. I know that sounds crazy, but yes, I really believe that. A natural number that has exactly 2 different factors, only itself and 1, is called a prime number. And they will ask you to identify prime numbers. Like 11, only 1 times 11 is 11, so 11 is a prime. Now they call 12, now 1 times 12 is 12, but also 3 times 4, so that means it is not a prime, and they call that a composite number. And we'll talk about that again in a little bit. They ask you to identify these things. N over 0 is also n divided by 0. It's not defined. You cannot divide by 0. Okay, it's just impossible. Now, the best way I can try to do, I'm going to do a super fast mini proof of this. If I do 10 divided by 5, I go 5 plus 5. Now that's 10. That only took 2 times, so 10 divided by 5 is 2. If I do 10 divided by 2, I do 1, 2, 3, 4, 5. That's 10. So there's this. So the answer is 5 because there are 5 2's there. Now if I do 10 divided by 0, if I write 0 plus 0 plus 0 plus 0, now I can keep writing zeros to infinity and I will never make it to 10, and that is why it is not defined. Can't divide by 0. Calculator doesn't like it either. A fraction is reduced or simplified when it has the smallest numerator and the smallest denominator. And we will be reducing some fractions. Now, before we get to reducing fractions, it's always helpful to know the division rules. And so we have just the numbers between 2 and 10. We have a couple of them. Not all of them have good ones. But these are the good ones that we think will be most helpful for you. A number is divisible by 2 if it's an even number. So in other words, the ones digit just has to be even. That last digit, or the ones digit right there, is even, so that is divisible by 2. These numbers before it mean nothing. It's only the ones digit. This ones digit is a 3. That's an odd number, so no. This ends in a 2. Even though 3, 7, 9, and 5 are all odd, it doesn't matter. It's just the ones digit, so that is correct. And just the opposite. 2, 4, 6, and 8, those are all even, but who cares? The ones digit is a 1, so it is not. 3. This is the one where you got to add up the digits. The sum of its digits is divisible by 3. 1 plus 2 is 3. 3 goes into 3, so 12 is divisible by 3. Now that one, again, you can just look on the chart. It's super easy. But once we start getting bigger, as you see to the right, Now 9 plus 5 is 14. 3 does not go into 14, so 3 does not go into 95. Now we're way off the chart here. 3 does not go into, well, I mean, it's not on the chart up to 201, but 2 plus 0 plus 1 is 3. 3 goes into 3, so 3 does go into 201. So this one, 4 plus 5 is 9, 9 plus 6 is 15, 16, 17, 18. So the sum of the digits 18, 3 goes into 18, 3 goes into 45,621. And I did not have to do long division on these things. I'm just using the sum of the digits rule. Now, the sum of the digits rule only works on 3s, and also it will work on 9, and we'll go over that. But these rules are not interchangeable. The rules for 4 is another really good one. If its last 2 digits, it's divisible by 4. Now right here, I took this off the multiplication chart. That's all the multiples of 4 up to 100. So every one of these numbers is divisible by 4. So now, if I look at the last 2 digits, 98, if I look up the chart, it goes from 96 to 100. That is not on it, so that is not divisible by 4. I look at 60. There's 60 on there, so that is divisible by 4. I look at 24. 24 is divisible by 4. That whole number is divisible by 4. 14. 14 is not there. There goes 12, 16, so that is not divisible by 4. The number is divisible by 5 if its ones digit is 0 or 5. That is a 5 in the ones digit. We're good. That is not. And that's a 0. That's an easy one. 6 is probably the most annoying of them. Takes a little bit. In the questions, the homework questions, they give you quite a few numbers to look at, so that also makes it a little more difficult. But for 6, it has to be an even number and divisible by 3. So now, this is an even number, 0, so I'm going to see if it's divisible by 3. 8 plus 4 is 12 plus 0 is, so that's 12. 3 goes into 12, so 6 goes into 840. Now, this is an odd number, so I'm not even going to bother trying. Now, the tricky part on this one, if I did try, 9 plus 3 is 12, 3 does go into 12, 93 is divisible by 3, but that's not good enough. It has to be even and divisible by 3. All right, this is an even number, so I will try. 3 plus 6 is 9, 9 plus 2 is 11. 11 is not divisible by 3, so that doesn't work. 2, well, it's an even number because the 4 is there. 2 plus 7 is 9, plus 2 is 11, plus 4 is 15. 3 goes into 15, so 6 goes into that. Now 9 is very similar to 3. You just add up the digits and see if it's divisible by itself. 4 plus 8 is 12. 12 plus 2 is 14. 14 plus 4 is 18. 9 does go into 18, so 9 goes into that. 1 plus 1 is 2, plus 5 is 7. 9 does not go into 7, doesn't work. 7, 8, 9, that's the sum of the digits, so that does work. 10, it's just got to end in a 0. I don't even bother doing an example for this because this is too easy for one. Ends in a 0, it's divisible by 10. Exponential notation. A lot of people get this wrong the first time just because they don't understand what the question's asking. Once you see it, normally people don't make mistakes, and if there are mistakes, they're really silly, and you're going, I cannot believe I just did that. All you have to do is count up how many 4s there are. 1, 2, 3, 4, 5, 6. So instead of writing that out 6 times, we do 4 to the 6th power. The 6 is an exponent. Long division. Nobody likes this. This is the multiples of 9. With the multiplication chart, this really isn't that bad. So, now I can't draw, couldn't figure out how to write it on the computer. So I just have it written like that. So I hand draw on the long division symbol. Now 9 goes into 142. Now what we can do, if the numbers go up high enough, if you look here, we're looking for 142, but there's 135, 144. 144 is too high, so I want this one. So now I got to figure out how many times that is. Now the multiplication chart is easier. You're just going to look straight up to find out what number is there. But since it's not here, we're just going to count. There's 1, 2, 3, 4, 5, 6, 15. So 9 times 15 is 135. So I'm going to write 15 up there, 135 there, and then I subtract. Now I can't do 2 minus 5, so I got to borrow from the 4. 3, 12 minus 5 is 7, 13 minus 13 is 0. So it's 15 remainder 7. Now they're also going to show you how to do this a little differently. They're going to say 15 and 7/9. So write it as a mixed number. Now, what's also nice is, let's say I do 9 into 142. Let's say it didn't have that all the way. Let's say I only had up to 10. So I didn't have all the way up there. So what I need to do is I need to break it into steps. 9 goes into 14. Well, 14, that 18 is too big, so it only goes in once. So then I write 9, then I subtract. 14 minus 9 is 5. Then I bring down the 2. How many times is 9 going to 52 without going over? Well, there's 54, 45, so 54 is too big, so it's got to be 45, so it's 5, so it's 5. Then I write 45, 52 minus 45 is 7, and then I get the same answer, 15 remainder 7. So both work. Sometimes you have to do it step by step. This next one we have to do step by step. That's why I made the overemphasis on the other one. 14. Now normally dividing by 14 stings because it's a terrible number, but as long as we have the multiplication chart, I'll be honest, got no sympathy for you. You can handle all of this stuff. Now, 85/12, it only goes up to 350. So we have to go step by step. Now, how many times does 14 go into 85 without going over? Well, we have 84 right here. So I'm going to write 84 below. Now this is 1, 2, 3, 4, 5, 6, who goes in 6 times. So 6 times 14 is 84. I subtract. 5 minus 4 is 1. I bring down the 1. Now here's a tricky one, and they love trying to trick you with this. 14, does 14 go into 11? Well, the lowest number is 14, isn't it? So it does not go into that. So now when I bring down a number, and this is smaller than what I'm dividing by, I have to put a 0 there. I have to hold that place. And that's very tricky. And then I got to bring down the 2. So I'm looking for 112. Oh, look at that. It's right there. It's on there. So 1, 2, 3, 4, 5, 6, 7, 8. So it actually goes in 8 times. 112, 0 left over. It goes in evenly. Alrighty, now we're going to be doing a little bit of long division here. In 1C, we'll be doing a little bit more, but this is a good start on it to practice. But again, use your multiplication chart. Okay, now I'm going to do a couple more, then I'm going to take a break. I try to make these videos around 15 to 20 minutes long, and we're almost at the 13-minute mark. Determine whether the following number is prime, composite, or neither. Now remember, prime, only 1 in itself goes into it. Now 41 is only divisible by 1 and 41, so this would be a prime number. Now 42, I know 2 goes into it because it's an even number. So I know it has more than 1 in itself as factors, so this is automatically a composite. 43 is, again, only 1 in 43, so that's a prime number. Now, if you notice that's an odd number, that's an odd number, but it doesn't always mean an odd number guarantees it's going to be a prime. Now 57 here, it ends in a 7, so people go, oh, it must be prime. Now, not necessarily here. Now, if we just use the simple rules we talked about earlier, is this divisible by 3? Well, 5 plus 7 is 12. 3 goes into 12, so 3 times something is 57. Now, I don't know what it is, but if you look on your multiplication chart, you'll see it's 19. So if there's 157 and then 3 19ths, that means this is a composite again. Now, they don't ask this on the tests or quizzes, but it is in the homework. 1 is the only one that is considered neither. It's to be a prime number, 1 and itself have to be its factor. Now 1 is itself, so it can't be 1 in itself, and it's a technicality. So I'm going to do the prime factorizations here. Now I always like to do the factor tree. And so I'm going to split this like this. What are the only factors of 35? 5 and 7. So now if I do 5 times 7, that's 35. 5 and 7 are both prime numbers because only 1 in itself. So really this is just 5 times 7. That's the prime factorization. Now 120. We could do this lots of different ways, and they are all correct. Now I'm just going to do 2 different ways because I'm not going to go crazy on it. But the easiest one, it ends in a 0, so I know 10 goes into it. So I would think 10 and 12 is my first thing. Now 10 is not a prime because 2 times 5 goes into 10. So I can split that into 2 and 5. Now 2 is prime. 2 is an even number, but it is the only even number that's prime because only 1 times 2 is 2. 5 is prime, so I'm just going to circle both of those because those are both prime. Now 12, again, I could do 2 different options. I could do 3 times 4 or 2 times 6. Doesn't matter. Oh, let's do 2 times 6. Now 2 is a prime number again, but 6 is not because I can split that into 2 times 3. Now those are all the prime numbers. Now, doesn't matter what order. I could literally write 2 times 5 times 2 times 2 times 3, and it will take that as a correct answer. Now, I'm going to do this slightly different here. I'm going to choose a different color here. Let's do 120 over here. Oh, let's try 4 times 30. Now, 4 is not a prime number because I can split that into 2 and 2. So I can circle both of those because those are prime. Now, 30 could be written as 5 and 6, as well as 3 and 10, and 2 and 15. There's, again, options. 5 is prime, so I'm going to circle it. 6 is 2 and 3, so I'm going to circle both of those. So I have 1, 2, 3 2s, 1, 2, 3 2s, 1, 3, 1, 5, 1, 3, 1, 5. So they give the exact same answer. You could write it in either order, it does not matter. What they'll want you to do is type it in, so 2 times 5 times 2 times 2 times 3. Now, if you get it wrong, they'll put it in numerical order, but you don't have to do that. 25 here, or 525. You want to look at the multiplication chart, and luckily enough, it is on there. It is actually 21 times 25. 21 is not prime because I can break this into 3 times 7. Now 3 and 7 are both prime. Now 25 is not prime. I can do 5 times 5. But 5 is prime. So this one will be 3 times 7 times 5 times 5. And there's your answer for that. Okay. Now, let's do this last question, and then I'm going to take a break, and then I'll do a part 2 on this. Circle all fractions below that equal to 1. You just have to remember, anything over itself is equal to 1. So if I have 5 over 5, that's equal to 1. 10 over 10, anything over itself. So now 1 over 0, that is not itself, that is not itself. 12 over 12 is, no, no. And this is x over x, and yes, that is. Now, if you get into upper level math, they'll argue that there needs to be something that says x cannot equal 0, because you can't have 0 on the bottom. So I guess technically 0 over 0 is not equal to 1. But we're being fussy about that one. All right, so that's the end of the first part of the 1A notes. I'm going to take a break, and then I'm going to put this up, and we'll have the other one.